So there's a little left over. Great. I can use that in some other math later in the week. Just a reminder that we don't use repeating decimals or remainders, fractions in our measurements, and you will always record your measurements as accurate as you can, and the last digit is a guess signifying the preceding measurements that have been recorded have some sort of target or accepted value on them. So a little review of the rulers lesson from previously. Today we're looking at these questions. What is mass? What is volume? What is density? We're going to go ahead and start in the middle here with what is volume. Volume is typically described as the number of cubes that fit inside something. Number of cubes that fit inside something. So the total volume being 36 cubed because we have one layer of 12 and 3 total layers of 12. So that 3 times 12 giving you 36. A classic from your youth is the formula for volume being length times width times height. It doesn't matter which you consider to be height, length, or width, but volume is length times width times height. It's 3 dimensions. Hence, volume, the number of cubes that fit in something. Calculating volume is another area where I like to show you the benefits of using the International System, or SI. Would you rather calculate 49 F words, 4 5/8 I words, times 24 F words, 8 1/8 of an I word, times 12 F words, 7 3/8 of an I word? Or would you prefer to calculate 15 5/100 of a meter, times 7 52/100 of a meter, times 3 85/100 of a meter? I think most of us would agree with B. Even if we change one of these to centimeters, we probably still prefer to calculate this. And this up here, you've got to change these fractions to whole numbers, add them to the previous bigger unit. Here, you can just straight across multiply those 3 values. So a nice benefit of the metric system where we don't focus on the fractions, although recognizing decimals are a form of fraction. The instrument, scientific tool that we use to measure volume is called a graduated cylinder. And they come in various shapes, sizes, models, images of graduated cylinder. They're called a graduated cylinder because they're cylinder shape, and then the gradients that are on that graduated cylinder. We won't always sound smarticle in the world of science, so we don't say measure to the bottom of the dip of the water. We say measure to the bottom of the meniscus. So we wouldn't register this as up to the sides. We would measure to the bottom of this meniscus right here. You're probably familiar with the term meniscus as things that your body has. A classic example being your knee, or meniscus in your knee, protect your patella, your kneecap. Again, it's a graduated cylinder because we have the gradients, these accuracy measurements on our device that we're using to measure volume. This one expanded view, that just happens to be 1/10 of a milliliter. 1/10 marks of these milliliters. In your study guide, you have a practice where you would jot down the measurement of this particular graduated cylinder, reading to the bottom of the meniscus. We're accurate to the past the 35 to the 40. So these aren't 10th marks. These are whole number marks. This is 35, 36, not quite to the 37, 38, 39, just checking 40. So we're accurate past the 35, 36, not quite the 37. So 36. We're accurate. We don't have any more marks in here, but we want to make the person checking our values of our data know that this is accurate. So we're going to show that there's no more marks in here, no more levels of accuracy or accepted values. Put a guess. Maybe it's 4/10. So we put a 4 here. And this 4, this being a guess, makes the rest of these known as accurate. And of course the units on the study guide printed, it says these are in units of milliliters. So we'd have 36 4/10 of a milliliter. Or you could have 36 3/10, 5/10. This number is a guess. This is here to show these had measurement lines. There were levels of accuracy on the measuring tool. This is what 1 liter cube would look like. Now, it's not quite to scale unless your computer screen is showing this as exactly 1 centimeter. But if I take a centimeter by a centimeter by a centimeter, 3 dimensions. So we have a centimeter by centimeter by centimeter, centimeter cubed. This centimeter cubed, if I had 1,000 of these centimeters cubed, 1,000 of these represented here, that is 1 liter, or 1 capital L, as you'll commonly see as well. 1 liter. The SI prefixes work just as well with volume as they do length. So if this is, say, 1/1000th of a liter, 1/1000th of a liter, we would also call that 1 milliliter. Just as the previous item here, these were in units of milliliters. 1 liter cube, if I take 1/1000th of it, it's a centimeter by centimeter by centimeter, which relates the way in which in the metric system, the international system, the unit of length, centimeters here, a unit of length, meter being the SI unit of length, the length is connected to your fluid, liquid measurements. And here's that connection. 1,000 centimeters cubed is the same thing as 1,000 milliliters. And 1,000 milliliters is most definitely 1 liter. Definitely want to get in your notes this connection, that 1 centimeter cubed is the same as 1 milliliter. And of course, vice versa. We will in physics be using centimeters cubed and milliliters interchangeably. The volume of this, 1 centimeter by 1 centimeter by 1 centimeter. Hence the volume of the cube, 1 centimeter cubed, or we could also call 1 milliliter. Page 0 in your study guide, we can add to the information we have here. The symbol for time is a lowercase t. The SI unit, we use seconds most often in physics, and it's a lowercase s, not SEC. The description of time, it's one of the most difficult questions among the world of physics. What is time? How do you describe time? You know, the passage from one event to another. And the measuring device, a stopwatch or a clock. Length, the symbol is L. The SI unit is a meter. The description of length is, you know, distance between 2 points, or from point A to point B. That would work. Whatever words work to help you remember what length is in your mind is fine here. The measuring device would be a meter stick. Ruler also would be acceptable. And we can go to volume now. Volume, the symbol is a capital V. The SI unit is the liter, sometimes in a capital L. That's a comma there. The description of volume, number of cubes that fit in an object. And we use a graduated cylinder. Skipping to what is mass. Mass is how much matter, a measure of how much matter an object has. Specifically, matter is atoms. You'll have a study guide on this course that will look a little bit more detailed at the atom, not quite to the level your chemistry class will or has, but mass is essentially how much matter, how many particles. This distance right here is being represented of 1 centimeter. This is also a centimeter. This is also a centimeter. So we do have on this balance, we do have a centimeter cubed. Now it's just listed as 1 centimeter as the distance from here to here, but this is a centimeter cubed. And one of the great things about the metric system is how the length measures turn into a volume measure, or are connected to a length measure. Same pattern will hold, that a volume measurement is going to translate into a nice convenient means of thinking of mass. The mass of 1 centimeter cubed, or 1 milliliter, or essentially a drop of water, is about 1 gram. 1 centimeter cubed has a mass of about 1 gram. Extend that further, 1 liter of water has a mass of 1 kilogram. Again, in your upcoming study guides, you'll look at the atom a little bit more. We won't go quite into the detail that your chemistry teachers will or have done with you on the various atoms, type of matter, molecules, compounds, elements of the periodic table. The instrument that we use to measure mass is a balance, or you can say balance scale, but don't say scale by itself, as there could also be spring scales that we will use in your next section of physics. So we have a balance scale. The way you use a balance scale is you take your unknown mass, or not sure, the mass of the bowling ball or the basketball, that's our unknowns. And we get the balance to be balanced, level, by adding masses that will make this side level. Of course, a basketball has less mass than the bowling ball, so less masses to get it to equilibrium or to a balance point. Let's say this is 1 kilogram. We'd call that basketball 1 kilogram. It's probably not 1 kilogram, but comparison, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the bowling ball makes up 10 known masses, maybe kilograms. The balances that you have in your laboratory to work with are these balances. And we can go to page 0 and add mass. Our symbol for mass is a lowercase m, which is frustrating as the SI unit for length is also lowercase m, not for mass but meter. Now the SI unit for mass, we have our base steps in the metric system. We have the 3 below and the 3 above our base step. And the base step can be anything. Like, you can interpret that to read as anything besides maybe the word base. But the base step for length has been meter. The base step for volume is liter. The base step for matter is the gram. Now, also, the SI unit for length is the meter. The SI unit for volume is the liter. But be careful, base step doesn't always mean the official SI unit, because the SI unit for mass is actually the kilogram. The kilogram. So this step right here is the SI unit for mass. The other two, length and volume, measured in meters and liters, the base step happens to be the SI unit. So be very careful in recognizing the official SI unit of mass is the kilogram, not the base step of gram that you're used to with other quantities. Mass is how much matter an object has, and the measuring device is a balance or balance scale. Don't just put scale, you want to specify balance scale. So this leads us to the underlying question of what is density? Now your go-to definition in a search engine, Oxford English Dictionary, Webster Dictionary, probably be a little bit more specific, but I try to think of density in terms of the compactness of an object. How compact are the particles in a particular volume or particular amount of something that you're holding something in? So mass, the volume connected to density, we'll look closer at that next, but overall density is kind of the compactness of an object.